Welcome to section 6.1, where we'll be talking about exponential functions. All right, our objectives for this section are to be able to evaluate exponential functions, find the equation for an exponential function, use compound interest formulas, and then work with the value exponential functions that use base e. All right, let's get started and talk about identifying exponential functions. So when x, the input variable, is in the exponent, generally it's an exponential function. That's a quick way to check. So which of the following functions qualify as exponential functions? Why don't you take a second and look and see which of these have the input in the exponent? All right, hopefully you're back from pausing the video and let's take a look. How about f of t equals 56 to the t? Yep, that's an exponential. Oh, I don't have a pen going here. Yes, that's an exponential function because your variable here is up in the exponent, so yes. And e to the x, yep, also an exponential function. We're going to be talking about this one later. 56v minus 1 cubed. Nope, not an exponential function. The variable is not in the exponent. And likewise, t of n, not an exponential function, because the variable is in the base. 1/7 is the exponent. All right. The general form of an exponential function is written as f of x equals a times b to the x. Let's just take a moment to remember what we talked about when we did linear functions. Remember, those had a form too. They were mx plus b. And the m told us the slope, which told us how the function changed. And b was the vertical intercept, which sort of told us the starting point, especially when we were dealing with like time as the independent variable. So if we had an example of like f of x equals 2x plus 1, that told us the slope was 2. So each time the input increased by 1 unit, the output increased by 2. And we also know that when x is 0, or the starting point, or maybe where it crosses the y-axis, the output is 1, meaning it's sort of our initial value. So just remember that's how it was with linear functions. It's a similar idea with exponential functions. So let's talk about exponential functions. So if we look at the general form of an exponential function, this time our a value out front, this tells us your starting point or your y-intercept. Okay, just like the y-intercept value. And why would that be true? This is our starting point, right? Well, it's important to remember a key fact about exponentials. If we plug in 0 for x, that always gives us our y-intercept, we will get a times b to the 0. Any number to the 0th exponent is equal to 0. Any number but 0. 0 to the 0 is undefined. So this is the same as a times 1, which is just a. So your a value is you're going to represent your y-intercept value or your starting point. So let's just, up here, and then remember, let's just write down what I just said about exponents. Any number to the 0th power is equal to 1 except 0. 0 to the 0 is undefined. Just recall that from properties of exponents. All right, and the b value refers to how it changes. Okay, this tells you how the exponential changes. And in fact, it's going to be the percent change. Percent change with exponents. So the percent change refers to a change based on the percent of the original amount. And we're going to practice with these, don't worry. If it's exponential growth, that means it's going to be a percent increase each year or each time unit. So if it's a 2% increase per year, it's 2% each year on the next previous year's value. 2% more than the previous year's value, 2% more. If it's a percent decrease, then it would be like 2% less, 2% less, 2% less. So exponential decay means a percent decrease from the original amount over time. Now remember, this is different from linear functions because linears change by a fixed amount, not by a fixed percent. So while an exponential growth might grow 2% a year, a linear growth would go $2 per year or 2 whatever units per year, not 2%. Let's see if we can explore this by looking at an exponential function. All right, here's our exponential function given in a table. So if we put in, I'm not really sure why I gave the first value. Let's just kind of ignore the first row for now, and I'm going to start right here. I don't even know why I completely had that first row. It's not wrong, it's just a little bit misleading at this point. Let's start at the 0th value. So the first thing I told you was that your a value up here was going to be your y-intercept. So this tells me right off the bat that a is equal to 9 in this example. A equals 9, all right? Because I'm looking right here and I can see that when my input is 0, my output is equal to 9. So a is equal to 9. And now let's look at the change from year to year. So if I go from 9 to 7, 9 to 27, that's going to be 3 times as much, right? Because 9, let's write this in a neater way, 27 divided by 9 is equal to 3, right? It's not, and if I go the next time, 81 divided by 27, use your calculator, trust me, it's 3. 243 divided by 81 equals 3. So each time as I increase my input by one step, I triple my output, right? I triple my output. So what does that mean? It means it's not a linear function because a linear function goes up by the same amount. 27 minus 9 is 18, and 81 minus 27 is 50 something, certainly not 18, right? And 243 minus 81, certainly not 18. So we're not going by a fixed amount each time, we're tripling each time, all right? And actually the way we come up with this exponential function for this is that by looking at these changes, ratio changes that we computed here, that's actually going to be your B value, okay? So your A value you pick off right here from your y-intercept. So A comes from the y-intercept. And your B value comes from the ratios. So if I wanted to write down my equation, and I'm just going to call this x g of x because I just don't feel like mucking with another variable right now. I'm not sure why I did that. Okay, x f of g of x. My function g of x is equal to, well, I plug in my a value, which is 9 times 3 to the x. Okay, 9 times 3 to the x. And so finding your exponentials from a table is that simple. There's a couple things you do have to be careful of. You do have to be careful that you have the 0 value in the input column, because if you don't, you can't use this method to find the equation. And you also have to make sure that the inputs are going up by 1 each time. Going up by 1 each time, right? So my equation is 9 times 3 to the x. So we can actually check that. So let's check that for g of 3. We know that should be 243 equals 9 times 3 cubed. Well, 3 cubed is 27. So 9 times 27 is 243 because it's 3, carry the 6, 18, yeah, 243. So check. We check that value. All right, let's try and do this from a graph. It's the same idea, kind of like with linear equations, how we were able to do the same process for all linear equations. We sort of found the y-intercept. In that one, we used find the slope first, and then we would find the y-intercept. An exponential function, usually it's easier to find the y-intercept first. So find your a value first, and remember that's your y-intercept. So let's go ahead and find that. That's pretty easy up this graph. It's 2, right? The y-intercept is 0, 2. So my a value in this equation is equal to 2. And the next step that we're going to do when we're finding the exponential equation from a graph is we're going to find our b value, our ratios, right? And these are ratios. Now you can read them right off the graph, but I personally think it's a little easier to do it by building up a table. So I'm just going to go ahead and build a table and make sure that I step by ones. Okay, so here's my input and here's my output. And the first easy one that I see is negative 1, 1, and then 0, 2, and then 1, 4, and that's enough for me for right now. And I can see my rate. These guys are going up by ones, which is what I need, right? Going up by ones. So my ratio is 2 to 1, which is 2. And then my ratio is 4 to 2, which is also 2. So I know my b value is equal to 2. So my equation is f of x equals 2 times 2 to the x. 2 times 2 to the x. All right. Let's do an exponential given 2 points. Well, first of all, if you were only given 2 points, just to clarify this example, if you were given 2 points, you need to be told, oh, I don't want to do the linear one right now, we'll do the linear one next. If you were given 2 points, you need to be told that you just need to find the exponential between these two, okay? So that's something that you just have to be told ahead of time. If you're just given 2 points and just told to find any equation, you could find a linear equation, you could find an exponential, you could find a quadratic, heck. But make sure that in this example, we're being told that we're looking for an exponential. So what we're doing here is we're going to, well, right off the bat, we know this value, right? We know that a is equal to 8 because we're given the y-intercept value. And in these, you always will be given the y-intercept value until we start studying logarithms. So for now, you will always be given the y-intercept value. So right off, we know y, or f of x, equals 8 times b to the x. And now, how are we going to find the second value? Well, we don't have intermediate steps, right? On the graph and on the original table, we were given the 0 value, the 1, the 2, the 3, and we were able to just look at the ratios. So we're going to have to do a different method to find b. We're still finding, to find b. We still found a first. That was still step 1, find a. We just read it off of here. Step 2 is going to have to be a little different, but it's similar to linear equations because we're just going to plug in the other point that we know. So we know that the point 3, 1 is on the graph. So that tells us that 1 equals 8 times b, we don't know, to the 3. 1 equals 8 times b to the 3. So I plugged in this point. The x value was 3 and the y value was 1, and I plugged it into my equation. So now I need to solve this equation for b. Well, how can I do that? Well, it's 1 equals 8 times b cubed. I need to undo by working outward in. So to undo the multiply by 8, I'm going to divide by 8. So 1/8 equals b cubed. I undo b cubed by doing a cube root. Cube root of 1/8 equals the cube root of b cubed. So this tells me that the cube root of 1/8, which is 1/2, equals b. So now I know the value for b. I plug in b and I get f of x equals 8 times 1/2 to the x as my equation. How did I know that the cube root of 1/8 was at 1/2? Well, one thing you can do is that you can actually plug it into your calculators. If you're not sure, you can plug it into your calculator, use the cube root function of 1/8. But also remember that the cube root is also means that a function times itself, number times itself 3 times would give you that. So the cube root of 1/8, I'm looking for the number that times itself 3 times, it gives me 1/8. I know that 1 times 1 times 1 would be in the numerator, right? That 1 times itself 1 time would be that. And so then I know that it must be 2 times 2 times 2 to get 8 in the denominator. If that makes any sense. All right, let's go reflect really quickly. I would like you to pause the video right now, and I would like you to find the linear equation that goes through the 2 points 0, 8 and 3, 1. Just to take a moment to review how to do this. Find the linear equation between these 2 points right now. All right, were you able to find it? Did you remember the first thing we do is find the slope? I hope so. Find the slope, which is y2 minus y1 over x2 minus x1, which in this case is going to be minus 7 over 3. And now you plug in one of these. So now we have y equals minus 7/3 x plus b. And now we find the y-intercept, which actually we were given, right? So we can just plug in this point if you want to. 8 equals minus 7/3 0 plus b. So 8 equals b. We already knew that. I just went through the work. What the heck? So my linear equation, g of x equals minus 7/3 x plus 8. Just to review the comparison between the two, finding the linear equation between 2 points and finding the exponential equation between 2 points. All right, that's it for the first video.